The conversion of 4 of Drax Power Station's generating units from coal to biomass allows it to offer dispatchable, renewable power, frequency response, inertia, and other energy security services to the grid. Bioenergy with carbon capture and storage, or BECCS, will see the addition of carbon capture and storage to Drax's generating units. This process will enable the power station to remove carbon from the atmosphere at scale and store it safely. Drax has invested millions financially and undertaken thousands of hours in developing, testing, and de-risking BECCS technology. We've also developed a world-leading network of partners, including Mitsubishi Heavy Industries, MHI, and startups such as Capture. Through our extensive experimentation and optimization, Drax and our partners have tested the performance of a range of carbon capture technologies for more than 6,000 pilot hours since September 2020. This includes testing for CO2 capture rate, thermal demand, and associated energy penalty, as well as the solvent's degradation and emissions characteristics. Drax has also evaluated carbon capture and utilization. There are a range of methods and processes for removing CO2 from an emission source. The solution currently selected for Drax Power Station uses a proprietary amine solvent. The carbon capture process works as follows. Flue gas, produced in the power generation process, is directed to the CO2 capture plant. Flue gas is cooled and then passes through the specialist packing media in the absorption tower, where the solvent meets the flue gas in a counter-current configuration. 95% of the CO2 is captured by the solvent. Then, solvent containing captured CO2 is pumped into the regeneration tower. Here, the solvent is heated with steam to release a high-purity stream of CO2, while the solvent is then recycled through the system to continue capturing carbon. The captured carbon is compressed to a supercritical state and is transported by a pipeline. When transported by a truck, rail, or ship, the CO2 is liquefied. The practice of injecting captured carbon into geological formations has been carried out since the 1970s. Once the CO2 is injected into the storage reservoir, it's trapped and immobilized by multiple physical and chemical processes and enclosed by the impermeable cap rock that overlies the reservoir. The overall process uses sustainably sourced biomass, which absorbs carbon as it grows. The biogenic carbon released in the electricity generation process is then captured. By storing it permanently and safely, BECCS removes carbon from the atmosphere on a vast scale. BECCS offers a high-integrity, high-quality form of carbon removal that can abate residual and historic emissions, helping companies and countries reach their net zero targets.